Hello everyone, this is AutoML and Training Working Group Community Meeting on 26th of June. This meeting is governed by the Kubeflow Code of Conduct, and this meeting will be recorded and published on YouTube. Welcome everyone. So maybe we can get started with a quick introduction. So do we have anyone here on the call who just want to introduce themselves to the community and just want to say hello? Yeah, actually, I think we can't hear you if you're speaking.
Can you hear me now?
Yeah, now we can, yep.
This is Akshay. Hi everyone, this is Akshay. I'm in the same team as Andre. I work as a backend engineer with Node's team at Apple. Been with Apple for 4 years, and I'm from Seattle.
Nice to see you. Thanks for joining, actually. Anyone else want to say hello before we get started? All right, so then maybe we can get started. So as I said, like feel free to add some items to the agenda. We have a few topics to discuss today. I think the most important one is the train job API updates, that we want to discuss today, and also the release updates. So from the release perspective, we released the first RC for training operator. I think it was a couple of days ago. So the RC1 for 1.8 is ready. So we already like updated the change log, and also we published the SDK and the controller to the registry. So feel free to use it and let us know if you see any errors or problems. And I think we're planning to cut the official 1.8 release this month or like in the first week of July before the Qflow 1.8 release. So we have a few bug fixes there. Specifically, we identified the issues with SDK. So we have like the problems with, if I just open the change log, just give me a second. So share my screen. Yeah, so we identify, first of all, we drop the support for Python 3.7. We kind of like following the same scheduler for Python versions as the official Python support. So we try to do the same for our SDKs. And also we think, well, like fix some issues with the transformers libraries for fine-tuning APIs. Because like we need to make sure these libraries are in sync with our trainer and the SDK version of the transformers. And we have some fixes for other like, imports and the get job logs APIs. And I guess like we also fix the Volcano version with the parameter there. So yes, like feel free to use it and let us know if you have any questions for RC1. I think for Ktip we're also ready. So we have this change log updated. So basically we have a few bug fixes for SDK. So similar to training operator, we right now dropping the support for 3.7, the Python version 3.7. We supporting the new version of protobuf, which actually allows us to integrate Ktip with Qflow pipelines right now because we supporting the recent version of protobuf. And also we finally migrating to the newer generator for gRPC code and like having some bug fixes for the controller and SDK. So this also should be working fine. I mean, we don't see any issues so far during the RC period from I think we started this in April. So I think we're good to go to make the official release very soon. Any questions for the release? All right, that sounds good. So I just want to maybe add before we discuss this the train job API proposal, a couple of things about GSOC. So we almost finalized the most of the proposals there. I think the progress is very good from the last month. We already started to do some implementation for push-based metrics collection for our tuning API for our like AT project, where basically we allow users to push metrics directly from their training script. So we kind of like we have some PR. So it would be nice if someone here in the community can help us to review them and also to provide feedback, so we can merge the changes faster and we can gather the feedback from other folks in the community. And I guess like we're almost like done with the enhancement proposals for three new features for Katip and the one feature for training operator. So just to like give you an update, we have a couple of new design for LLM tuning API, which we actually allow like users to quickly fine tune not the fine tune, basically tune the hyperparameters during the fine tuning of foundational models. So this is the proposal that is about. Also have like the proposal for supporting different parameter distribution within KDIP, like log uniform, which basically will make it more in sync with other like optimization frameworks like Aptuna or HyperOpt. And also we're supporting the push-based metrics collection, as I mentioned before. This is a proposal about where basically user can directly push metrics to the KTIP DB from the training code. And in training operator, we also have the proposal to supporting JAX here. So we have plans, I think, for the GSOC to supporting JAX within V1, but eventually we will migrate it to V2 once we finalize the design. But we just don't want to block our students for this work, so we can move forward to the implementation of JAX within Kubeflow training operator. For any questions? Um, Anything you want to discuss for the GSOC proposals? Any blockers maybe you have like from your side to move forward that you want to like, ask community for help? All right, that sounds good. So let's definitely stay like let us know if you see any like problems or you need any help from the community. And feel free to use Slack channels or the GitHub repo. Also, like just a reminder, I think in the last call we announced a new kind of like migration to the Slack. As a reminder, we have a new Slack. We're using CNCF right now. So please join the Kubeflow training and Kubeflow KDIP channels to discuss the training operator and KDIP projects so far in this new CNCF Slack. Yeah, so let's jump directly to this V2 APIs that we need to talk about. So it has been a while. So I think we iterated for these proposals for almost like 2 months already. So a couple of things we've been like just a couple of updates. We've been working on finalizing the design and discussing with a batch working group what should we do next with the V2 proposal. So if you get a chance, please review this doc. Let us know about your feedback. But I think like um, what is the stage right now that we believe that probably we can simplify the submission of training job and for distributed training or for fine tuning much better. For example, like we kind of like identify during our discussion what like the main motivation behind this proposal is to migrate to job sets, like using the job sets directly in training operator so we can leverage the job set functionality and simplify the orchestration of the distributed workers. So we don't need to manage it inside training operator. But we kind of like end up with a couple of like ideas and couple of suggestions that usually we have like few personas who are actually using this like the training operator eventually on Kubernetes, right? So we have a DevOps engineer persona who are actually aware of Kubernetes. They know how Kubernetes workloads are working. They know how to specify the Kubernetes APIs, the specification, but usually they don't really aware of the ML frameworks or ML algorithms, like a low-level implementation of how does it work. Also have an MLOps engineer who may be like aware of distributed capabilities of PyTorch. So maybe they know what is the PyTorch distributed. Maybe they know what is MPI, but sometimes they're not really familiar with Kubernetes spec or with ML algorithms and models. So usually like there is a kind of like a glue between a data scientist and DevOps engineer. And I have a data science persona. So which basically the person who is like whoever how to build these models, who knows how to use the Torch NN, for example, APIs for neural networks. So they know how to build models, how to use advanced algorithms, but usually they don't really know how to use Kubernetes or use a distributed capabilities of PyTorch, for example, right? Um, so I think we try to design API in a way of how it could, benefit everyone. Because on the training side, right, like the idea is to um, usually the data scientists, they do a lot of iteration before they kind of like prepare the model for inference. So they kind of like creating some model architecture, or they want to tweak some model architecture, and then they want to see what is the performance on your model during the training looks like. And sometimes you kind of like end up, they don't really usually change a lot of like distributed parameters. Like they don't really change a lot in like run policies or port failure policies or other like policies which can be like very specific for system level of orchestration. So I think like the main idea of the first idea was to again like just defining the spec which called train job, and inside train job we will define the whole like template similar to job set where you just define the different replicated specs. But I think like the problem with this, it kind of like easier than using directly job set, but at the same time, we kind of like we understand it is not necessary to like get all these parameters all the time you submitting your training job. So before I jump to the idea of runtimes, any questions so far? Any maybe different thoughts on the personas we're talking about? The users actually want to like pursue with this API? All right, so yeah, let me then move on. So yeah, the first proposal was to again using the train job where we defining the directly all the parameters, all of the policies, like gang scheduling policies, the suspend semantic, the manage by for queue, the TTL seconds after finished. So the parameter basically which defines when the job needs to be terminated after it completes, right? And also we have a template here where we define like each replica spec, where like user can specify the pod failure policies, the workers, and other parameters for the specific to the jobs. So the problem is like for the when we're submitting some training jobs, usually it is not required to modify some of these parameters. Then we kind of like, so the idea was we need to kind of like, as I said before, we need to like pre-create a list of the blueprints or the list of the training runtimes, which can be reused then by the data scientist when they actually use these blueprints in their training submission. So I still kind of like designing this, and I guess like this is similar to um, what we proposed in the batch working group before, what I guess like the folks from batch were working on the serving side. Um, so the idea is to let me just jump it here. Define a train job spec where we have the reference to the training runtime and the training config, the parameters that the data scientist can override. So again, the training runtime is a specific resource which will be useful for MLOps engineers and DevOps engineers, right? Who actually knows how to configure distributed parameters, who knows how to configure like, backend side of things like volume storage or like failure policies, for example, and doesn't really need to be modified frequently when you creating the job, right? Um, so this is at least like from our discussion with different folks who are using training operated in production, right? They usually have a specific setup that they use all the time, and maybe they do some sort of the changing like changes very like not frequently. And the idea is like to provide and this is like again early. I still think about like the how the parameters for data scientists might look like, but from the data science perspective, what they only need to modify is the trainer source, like what is the source of that training code. And here we have also like several options. Like for example, data scientists can provide an image they kind of like pre-build. And this is also like the problem. Data scientists, they don't want to build an images, right? So we can provide an automation for them to build an images. For example, SDK, like Python SDK, which allows them to kind of like pre-build the image before they actually using the train job, and then we can like wrap everything under the Python SDK. But they can basically provide an image. They can also provide a serialized. So this is again, and we need to think about the name, but the idea is they can also provide the serialized function. So this is like how Spark operates today. So Spark behind the scenes using the Cloud Pickle library. So the Cloud Pickle library is actually the library which pickling the Python code in the bytes in the string, and we can actually serialize the Python code before actually sending this to the remote executors. So I think this could be also interesting for us to investigate. So how we can like serialize the user function before actually sending this to the training to the nodes, right, to the remote nodes, and then deserialize it when the training actually executing. So right now we have this capability similar to KFP, how we creating the component from function, where basically your function is the input for your image inside the arguments, kind of like it's kind of like inbuilt inside the arguments, and when the image is executed, we kind of like reading these arguments and executing this function. But I think we can do something more interesting with Cloud Pickle library when we can actually serialize the whole training code within the byte string and then pass it to the trainer. And also we can support other things like a Git source or like some other sources. I don't know, maybe S3 or anything else where actually your training code is located. This is like the main thing which data scientists usually need to tweak, right, before they start a training job, right? Um, so any questions so far for for this?
So in the training job spec, we're still providing like a full spec for the specific framework parameters, even though now we have this like, reference to the runtime. And
Yeah. Yeah, I think
it,
that would be not necessary, right? I mean, if I have the training config, right, we can only provide the minimum number of parameters that user can specify to override the blueprint.
exactly, yeah. And then that addresses the problem of like, like the workload owner who creates those jobs.
Yep.
Um, they're pretty much like protected from these like, changes. And also it's easier for us to extend as well in the future. Like you can create a new runtime.
Yep.
Basically, it's a new API and they can just basically use it when it's available instead of, I don't know, like us having to change this API, top level API every time.
Yeah. Yeah. I think like the the hard question we need to answer, like what parameters we want to expose to the data scientist, right? Um, because what if some data scientists want to have control over rendezvous backends? Do they, in that case, need to, work with the runtimes directly? If they're like kind of like more experienced, folks who know how to configure uh, the spec, right? The policies, for example, right? Like port failure policies. Um, so we need to see how to find a balance, right? Um, I think it is fine to, like redirect them to the runtimes directly and then asking them if they want to like create a job based on this runtime. Um, yeah, but I guess like the question is like what kind of parameters we want to like provide in a training config, right? Because I mean the obvious one is like the code when you want to execute, maybe like the model provider parameters. We kind of like have a initial proposal here, but we need to modify it. So basically, like what kind of model you want to download. Like if you do the fine tuning, for example, for fine tuning, you need to kind of download model. You also need to define the model source, um, and some other parameters for your model when you do the fine tuning, right? I guess like the transformer type, the access token if it is required to download model. So the question is like from the data science perspective. So I think first of all, we need to like distinguish, right? So there is there is a distributed training, there is a fine tuning, right? There is a like single worker training. and the multi. So this is like again connects to like the different kind of runtimes that we might have, right? So I guess like from the infrastructure side, we have a single role training runtime when we have a single worker, which actually can be represented inside the job. And then we have a multi-role training runtime when we have like multiple workers, like a launcher and worker, like parameter server, master and worker for MPI, for example, use cases, right? Like MPI has a launcher and workers. So for this specific thing, we need like a job set capabilities, right?
Yeah.
Yeah. Um,
I mean, the runtimes could be, again, like MPI training runtime, for example.
mhm.
Um,
Okay, so
basically,
yeah, good.
you're creating an API specific to describe how we want to run MPI jobs in general.
Yeah. I think like the problem is like there is a concept of framework and there is a concept of like of the like of different way how to do distributed training, because okay, MPI is always require launcher and workers, right? But like for PyTorch, for example, you can have like one master and one like multiple workers when you do when you need to do some initialization before actually start your distributed training, right? So I think the question how we can define these specs, these CRDs, right, for different use cases.
I mean, like if for example, like you could have like a PyTorch, for example, training runtime that would include things that are like the parameters that you have in the example above, right? Like
Yep.
now you can create different instances of that. Like that depends on how you want to run a PyTorch job. Like
Yep.
basically, that's at least how I see it. Like you can create multiple instances of those runtime, and then the workload owner would pick one of them, right?
Yeah. Yeah. Mhm.
Sorry, go ahead.
Yeah, I think like the question is like here we kind of like try to, so yes, PyTorch has a very specific parameter. So all these parameters can be specified inside the environment variables or like the input for your torch run command, right? For the runtime, the question is like, do we want to define this as the spec parameters, or
Okay.
like we want to define them directly in the input for our container? Because the runtime also includes the like the base image, I guess, like we need to maintain. Um, so the people who are actually executing the code can inherit from this image, right? While they're building the training code. Yeah, but this is separate, right? I mean, so I guess like for the framework specific runtimes, we might only have the policies which other frameworks like don't support, like Elastic policy, for example, right? Like Elastic right now is only supported inside PyTorch and maybe Pedal, and other like frameworks like TensorFlow doesn't support any Elastic capabilities right today. So in that case, do we want to be specific to the framework when we defining our runtimes?
I think.
Yeah.
I think so.
Yeah. You do you have any kind of like your opinion on like on the runtimes? Should they be specific to the framework, or they should be agnostic and maybe specific to the like distributed training techniques, or I don't know strategies we want to support?
I'm actually, so I have two questions updated this documentation.
Yep.
The first is there are two types of train job custom resource in this proposal. So which train jobs you want to propose? So the first is the first train job is under the train job section, and the second train job is under the runtime section. So which train job?
Yeah, I guess so our point is like there is no really like a lot of value of having this train job if we kind of like cover all the, you know, like use cases with the runtimes, right? Because like if you want to go lower level, you can always like, you know, use a job set directly. Or, you know, like so the problem is like with the job set today, it's only for MPI, to be honest, right? Or with the gang scheduling. And the gang scheduling problem is because Kubernetes doesn't support it out of the box, right? That we discussed. So all other things can be easily integrated inside the job set that we're talking about, right?
So you mean so
Mhm.
users can directly use job set instead of the first train job, right?
Yes, and yes, they can directly like, you know, construct the job set appropriately, right? With the parameters to cover the use cases, right? We're talking about
But so in that case, so users need to specify framework specific training environments and the pods and so on manually in the job set manifest,
yes,
right? So
that's correct.
so I think it's challenging for platform developers because some platform developers do not know framework specific specifications and environment variables. So I still think the first training job is useful for those developers.
But why, like, why do you don't think that the runtime idea won't be useful for them?
Sorry.
Why you don't think that the idea of the runtime, the blueprints, won't be useful for this set of folks that you're talking about, this set of users?
Sorry, which
Yeah, like
runtime?
the thing is like when you're talking about developers, right? You're talking about the people who actually creating the infrastructure for users to, you know, like to use the MPI jobs or PyTorch jobs or, you know, train jobs, right? So if we construct the runtime um, for them, right? So first, let me ask you for which kind of persona we're talking about? Is it data scientists, ML engineers, or what are those people?
So I wanted to indicate so platform developers without ML specific knowledge. So
Mhm.
um
So
and
what exactly?
so
Yeah, go ahead.
and so so as I can see the second train job, so the second train job does not have full control of batch of fields, right?
Yep, that's right.
So if so, how to specify failure policy and restart policies?
It is inside the training runtime, right? So single role training runtime. You have this whole job, and you also have the run policies. So the run policies, if you want, we can, you know, like override some parameters, right? Which like job or by job set doesn't support, right?
I
Um,
see.
yeah.
So if users want to
Mhm.
specify failure policy, so uh, we need users need to pre-create train config, right?
Yes, yes. We kind of like need to pre-create it, right? And we can again, we can if you think that this should call it PyTorch training runtime, I'm not like, you know, against it, right? Or API training runtime. We can always have a specific, you know, spec, which can be the specific to the, you know, PyTorch, right? Or API, right? And we can just pre-create it, right? Uh, beforehand, right? Uh, Yeah. So,
Mm,
and this is
so
again, yeah, good.
actually, so I want to create job via single API call. So
Mhm.
if the second train job approach,
Mhm.
in the second train job approach, so we need to two API calls to dedicated to job. So actually, so I'm thinking so if we can um if we can define more abstracted APIs like training runtime
Mhm.
and training config and so on based on train job. So I meant so um, uh, if we can um, if we can create training runtime API, so that so training so okay, so let's say once users create a training runtime new API, the training operator creates not abstracted API like train job.
Mhm.
So so I think that is so advantages to advantage so that we can give users full control of bad jobs, and we can give our advantage um, to uh, to more abstracted APIs to data scientist personal users, right?
Yeah. Uh, yeah, Abdul,
So actually, yeah,
go ahead. You go ahead.
actually, so
I just want to go ahead.
um, as I can see this proposal, so um, so we so the second train job and training runtime API is considered as a reversed concept compared with my proposal, right?
Um, yes, I have a couple of questions to you. Like, Abdul, do you want to go first? Like, I have just a few questions to you for.
Go ahead. Go ahead.
I just like wondering. So, for your use cases, like, like when you creating the job, do you need to change the policies frequently? I'm talking about port failure policies, runtime policies, scheduling policies, uh, number of workers. Like, do you need to change these parameters all the time?
Yes, actually, so in my case, so
Mhm.
I can I so platform teams cannot know which failure policy and success policy and run policies are used in data scientists and ML engineers
Yep.
in advance. So it's challenging to define those policies in advance.
And
So
who? Okay.
so so
Okay. Yeah. Go ahead.
so we want to so we want to leave knobs for full control of policies and batch job specs.
So how do you manage these run policies today? Like, how do you define which run policy you need to specify for a job?
So in my case,
Yes. Yes. Right now.
so currently, so we expose some abstracted Kubernetes APIs via in-house gRPC API.
Hmm.
And so data scientists and ML engineers can submit a job using the in-house gRPC API using in-house CRI and in-house web consoles and so on.
Yes, but so in this API, do you have like the ability to set the run policies?
Yes.
And who is setting these parameters? Like, how do you modify them?
So so currently, so users can specify so so in-house CRI. So not kube control. So so users specify run policies and job specs every submitting jobs.
So users, we're talking about not data scientists, right? The users, like engineers, right?
In my case, users is researchers, data scientists, and
Okay.
ML ops engineers. Yeah.
So how this, again, as you said before, data scientists, they don't know how to specify these properties. How do they know what run policies they need to specify? Like, do I have any kind of instructions for them, or how do they understand?
Actually, platform team supports. So if you want to, so if you want to give in this case, if you want in this case, so you should specify this policy in this case, and so on. So I mean, so actually, so data scientists and researchers do not have knowledge for our policies. So our platform teams announces so how to specify run policy every situations.
Yeah, exactly. So like our idea is like the Protons team, like from our understanding, they can pre-create the runtimes for data scientists, right? So we can, because as you said before, data scientists don't know how to do it, we can pre-create it for them. So, and how to construct it to make it simpler for MLOps engineers, because I guess like from my understanding, the runtime here is like the spec for MLOps engineers, right? Who know like a little bit about Kubernetes and a little bit about like distributed capabilities of the framework, right? So they know what is like runable backends, they know what is torch run, they know what is like standalone mode, and they know how to specify queues, right? Gang scheduling, all these things they are aware. And they kind of like pre-create this, these blueprints or these templates for actually end users, data scientists, so they can quickly iterate on their experiments, right? Well, you also have a question. Go ahead.
I was actually going to probe and ask the exact same questions you were asking, Yuki.
Yeah.
Basically, what exactly the data scientist usually like varies, right? Like when they create their jobs, what are the parameters that they, when they create the job, care about and set? And it seems that in their case, they have an API that abstracts some of this, right? And you're exactly right. So what we're trying to do is to basically do the job of that API that you created, gRPC, in this template, design pattern where you can create instances of the code. It's actually more flexible for you, right? Like because the API is pretty much, if you want to change that RPC API, you have to change code to enable, disable new parameter or whatever. With this approach, you basically create easily like a new template, right? A new instance, right? Like if you want to vary a specific thing. It depends on how we design those, training runtimes. But I definitely see cases where it's easier basically to create a new flavor of PyTorch, for example, that you would be able to expose to your users. I mean, the idea here, you could also have some sort of like a tool that lists, oh, here are all the runtimes that you have, and here are the things that you can basically, how you can instantiate them. Again, to simplify the experience for the data scientist. I see similarities between this, by the way, and the K job that Marcin and Aldo proposed in working group batch. But it's a much narrower in scope, to be frank.
Yeah. Yeah, I think
see.
yeah. Go ahead. Kiki.
Yeah, I agree with you. So okay, so if we select the second train job schema, so will we provide some templates for distributed training, so like Elastic,
Yeah, I think
PyTorch, and so on?
so. Yeah, I think the idea is, first of all, runtime is immutable, like similar to like what you block proposed for serving. I think it's also applicable for training. Like, yes, out of the box, like we as a community should support several runtimes. Like we should support, PyTorch, XGBoost, TensorFlow, DeepSpeed with MPI, maybe like JAX or other runtime. Yes, we should support them. But we should also make it extensible for users to create a custom runtime, right? That probably would just maybe don't support. But I think eventually we should provide a list of, state-of-the-art runtimes for people to reuse in their training. So the only questions actually that I have, how we can distinguish fine-tuning from training, right? Because from the orchestration perspective, I don't see a lot of differences in fine-tuning and distributed training from the scheduling policies, from like just the initialization is slightly different. Um, but I think the question is like how we want to construct the runtimes to fit different use cases, right? Because today people don't do a lot of training, right? They do just fine tuning, right? Most of
Right.
the 90% of the use cases, right? So the question
Do
is like
you have a description of the fine-tuning use case, or what is exactly like when you try to do fine-tuning?
Mhm.
And forget about like a training job API.
Yep.
How would we be able? How, what would we need to create to express that fine-tuned job? Assume that you're creating everything like manually yourself. You're creating a job or a job set. You're creating a PVC or whatever, like all these resources that you want to create to express that fine-tuned job in Kubernetes. From there, we can look at, okay, how do we package it in a runtime in a proper way?
Yeah, I mean, from the user perspective, there is no real differences. They just take the pre-trained model and the adapters, right? I mean, if they use LoRa, they can like tune the adapters, and then they like there is a concept of LoRa. When they tune the adapters, they store these adapters in some blob storage, and then they use these adapters when they do the inference, right?
Yeah,
Also, yeah, go ahead.
but like, how do we express all of this in Kubernetes? I think is my question. Like, do you usually have the adapters in a separate bucket from the base model? Do you need to express them differently? What
Mhm.
exactly you want to create, the Kubernetes resources you need to create just to run and iterate over a fine-tuning job?
Mhm. Um,
Because you're saying like you're not sure about this versus like the fine-tuned use case versus the training. And I'm trying to understand what's the difference.
um, so from the user perspective, there is, because they're still using the PyTorch or Hugging Face API, right? So PyTorch allows you to actually like loads the pre-trained model to the PyTorch class, right? To the model
Mhm.
object, right? Which means like from the user perspective, they do exactly the same, right? They just don't really create the model architecture. They just take the instance of the existing model and then they do additional training on top, right? Like the difference between adapters and fine-tuning without adapters is just like the final artifact is just the like the adapter that you need to like serve. You need to basically use when they do the model serving, right?
Yeah.
Yeah. So I don't see a lot of differences. It's only the difference inside the initialization, right? When you need to upload the model. And basically that's it, right? You also need to do the data pre-processing, right? Like the tokenization, but this is not related to fine-tuning, right? It's mostly for NLP, like kind of like data
Mhm.
preparation, right? For your model training. Um, yeah, I think It's mostly so the difference would be between like fine tuning and like the training. It's only like user will have this kind of model provider. Like I don't we still need to think about these parameters, like whether they should be exposed as part of the training config, trainer like training config where user can specify the dataset source, model source, right? Like um um or it should be like I guess like from my understanding, these parameters is part of the train job spec, like part of the data scientist parameters, right? Which they want to specify.
I see.
Yeah. I still, yeah. Any other question? Any suggestions? Maybe any questions from other folks?
So may I ask a question?
Yeah,
So
go ahead.
so actually, so I'm not sure what is difference is training runtime and training config responsibility.
Yeah, so this is specifically for data scientists, what they need to tweak, right? What data scientists need to tweak regularly when they do when they submit the train job. So we need to speak like with the community, with data scientists, what they usually want to modify. Maybe like name of the accelerator, for example, or maybe number of accelerators. Even that I don't know. Like because for example, like they know they have like 5 GPUs, right? They want to like use this 5 GPUs to train my model, right? And then we do everything inside our runtimes, right? And inside our template. So we will modify the number of workers. We will modify number of processes per workers, right? So these kind of parameters, right? So basically, like the scaling config, maybe we can call it, right? I don't know. Like we can think about it, right? How to call it. But these parameters could be like very specific for like that is what they change regularly. So the one obvious thing is like training source, right? What actually like the code of the training script. Also like a model, like for fine tuning, for example, they only need to change the model provider, dataset provider. Also I hear the use cases, for example, like when data scientists want to do the fine tuning, but they also want to tweak the model architecture. So I haven't thought about this during our LLM tuning API. So recently, just let me remind everyone. So we integrated this Python API where people can just, when user just can specify the model provider in Python, dataset provider, and the trainer parameter. So this is the Hugging Face trainer parameters, like what kind of, how many epochs, what is lower config, and then they have like number of workers and number of processes per workers. So I got the request from the scientists that this is great, but sometimes they need to tweak the model architecture during the fine tuning. So how we can make it simple, right? Because this API, like right now, doesn't support it today, right?
Okay. So if so we will move model parameters and dataset parameters to train config, right?
Yep. Or we can have it separate, right? I mean, it's I guess up to us to decide. We can maybe have a dataset config, right? Or maybe something like this, right? Because sometimes maybe user doesn't want to specify the dataset config, right? But we can define like so this should be like a very specific spec for data scientists, like not like for things that needs to be changed regularly every time users submit the job, right? Does make sense?
Yeah, makes sense.
Yeah, so and that is like I want to hear like from maybe like from the community, like what is the parameters usually data scientists changing? Like you can from your experience, what kind of parameters like your data scientists have on API front, right? When they submit the jobs.
Actually, data scientists want to modify so image name and the commands and args and
Okay. Yeah, environments, right?
yes, environments and credentials.
Yeah, secrets. I think secrets. Yeah, so definitely. So I guess like the question is like secrets can be personalized. Maybe some secrets needs to be passed directly from the user. The problem is like different systems might have a different way of doing secrets, right? What things when you want to support here, right? But yeah, I think like it's can be part of the trainer source, right? So if trainer source, for example, is the image, we can also give them an ability to specify the arguments. Yeah, maybe arguments, right? Maybe they kind of like can pre-build an image and they will just want to directly push this image with custom arguments, right? So maybe args could be part of this spec, right? Somehow.
I see. So so here's my question. So so this trainer source can be
Yep.
specified every for
Yeah.
roles. So right, because every for workers and masters and so on. So or
Yeah.
so
Mhm.
we only specify a single trainer source for a whole of train job.
Yes, it's only like for the trainer by itself, right? Not like for if you have a different image for worker and executors, like launcher and executors, like I want to ask a question, when do I have this? Like, is it for MPI use case? But for MPI, do you need to modify the launcher image, or launcher will have a pre-created, template? Um, yeah, I need to. So I need to ask for the use cases when you need to when you need to have more than one image source, basically, right, for your train job.
Yeah, actually, so we can reuse image for all roles.
Yeah,
Um,
exactly.
but so commands and args maybe want to specify. So maybe so we want to specify different commands and args to every roles, right? So
Yeah,
so for example, so if we want to initialize dataset initialization only in master, so master roles, so we do not want to initialize dataset in the worker roles. So
yes,
actually, so yeah.
that's right. That's right. And this will be so data set provider, I guess, like I still need to construct the spec. We have some ideas before, right? That you have it here. I need to like revisit it. But I think for the other side, we just need to provide, like data set sources when we're going to support, S3, GCS, Azure, all these, data set sources that, we can construct maybe a storage initializer that we can ship as part of our images, right? So this could be, and data scientists can maybe just point to their allocation for this data. So similar to how we implement the fine-tuning, right, API. So again, this is very customizable. Like we kind of like create this dataset provider and model provider image, and this supports like multiple dataset providers. So today we support like Hugging Face Hub and S3, but we can support like more kind of dataset provider. It's some sort of like initialization part, right? And this is also could
Yeah.
be customizable because MLOps engineers can create their own custom providers and just plug in our, platform, training platform. I don't know, like in our training operator, if they want to have their own custom initializers for their data scientists, right?
Yeah, actually, so in ideal world, so MLOps engineers and platform developers need to implement custom provider for model
Yeah.
and dataset.
Yeah.
But so some users, so in POC phase, so some users want to modify commands to perform pre-processing and post-processing.
Yeah.
So
Mhm.
if we will not expose commands and eggs every 4 rows, so so it's challenging to implement model and dataset providers.
Yeah, I know we're time. Sorry. Feel free to drop. I think I need to also like drop some. I think it's fair if we can. Let's think about it more. I think like we can eventually provide a list of the again out of the box providers. Similar to Kserve. So Kserve today supports a lot of storage initializers for model to be downloaded on the every worker, right? When they do the inference. So we can do the same for training, right? We can just, provide a set of for the transformation. I think it's separate. Like if user wants to do some data preparation, do we want to support it, or like I think the question is like how do we want to support this data transformation, right? Should it be part of some sort of custom images, or it should be responsibility for user to define this data transformation before the training, right? Because eventually they can also do this on every worker, right? They can just do the data transformation this image. So I'm talking about this trainer. What is it? Just a second. This trainer source image, right? And they can do data transformation on every worker before they execute the training, right?
So I'm thinking, so if we can provide abstracted gRPC API, like Khatib suggestion services. So,
Okay.
so if ML ops engineers want to implement customized data pre-processing provider, and so we ML ops engineers can implement customized mechanism using our provided standardized gRPC API. So
yeah, you mean like
and
a
so
yeah, go ahead, sorry.
Data scientists and researchers can specify the custom dataset providers in the train source images section, right?
Yeah, exactly. Yes. So we can maybe, just give an user an option to specify an image in the dataset provider. I think that this would be possible because I think Ksurf also supports it out of the box. So they have like the list of the initializers, but you can always just directly use your custom provider, right?
Exactly. Yeah.
Yeah, this could be done. Yeah, I know over time. So I still need to design the spec for. I think what would be really useful if you can, maybe add the comments. What from your perspective is useful for data scientist persona? What kind of parameters can be part of the run policies here? Like one example is gang scheduling. Like gang scheduling is not supported by job set, is not supported right now by Kubernetes. So we have to do this in the, I guess, in the run policies somehow, right? So and also like the question how this runtime should look like, because today we discussed maybe this should be specific to framework like PyTorch training runtime, right? Or MPI training runtime. The question is like how then we can do MPI plus PyTorch. Like sometimes people can use MPI with PyTorch, MPI with DeepSpeed, or they can use SSL with PyTorch. So there are like different, combinations of training. We need to see what is the right spec for us to support different runtimes, right?
I'm actually I'm feeling so we can provide similar mechanism gateway API. Actually, gateway API provides so um provides provides a way to specify arbitrarity custom resources so that we can specify custom parameters. So maybe maybe we can define training config as a framework specific API. So
Yeah.
let's say so. Yeah.
Can you share you some examples? I will review it after the call. So
Yeah, sure.
all right, that sounds good. All right, we're over time. So any other questions? Maybe any comments, opinions on this proposal? right. I think it looks good then. So let's definitely. I will work this week to like finalize the spec for. And this is again not the name could be definitely changed. I don't like maybe we can think about the naming for for training. What is it? Um the training config, and also what should be part of the spec, which is useful for the designers when not for the designers, so it actually needs to be changed regularly on every time you're submitting the train job, right, on the control plane. So this is definitely could be part of the spec, so we can simplify the submission of the jobs. Yeah.
Yeah,
All right.
absolutely. Yeah.
Sounds good. So thanks everyone for your time. Let's definitely work this finalizing this week, and I guess like we will submit it soon on the training operator repo. And maybe just gather other feedback. I will ask existing users what do they think about it, what actually needs to be done as part of this implementation. Sounds good. Thank you so much for your time. Thank you. So see you soon. See everyone. See you in 2 weeks. Thank you.
See you.